Welcome to Strangeworks. Cool. I hope I'm able to share these video before they launch, because I really would love to. But I'm not going to show the platform. I don't think it's fair. I just wanted to play one of the introduction games that they have in there, which is called the it's called the how's it called? The Rubik's thing. So it's a really nice puzzle. That basically this is just some stuff with the company. I won't go through this in the video, but basically, yeah, the Rubik's sphere exactly. So the idea is, and wait a second, because I was told there's some spoilers in here, and I don't wanna, no, 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 don't look at the screen right now. Don't look at the screen right now. Don't look at the screen right now. There are some hints in here that I don't want to read, but yeah, that's the point. So. That a qubit is being basically spun in all directions, and then the idea is figure out, without knowing where the qubit is pointing at or what's the current state, figure out how can you make it to point to 0 with a probability of 1. Now I think there's a small mistake in here. 0 should be here, right? Never mind. But 0 with a probability of 1. So that's boo here, and that's the code. But we shouldn't be taking a look at these because you know it's trying to obscure where the qubit is really, and I'm going to try to solve that in two different ways. Maybe there's going to be just time for one in this video, but I'm definitely going to be another follow-up with these doing this. So first we'll just try. Okay, so we'll just try. Here's basically scramble the rotate. So then I scramble it by rotating it where here and there and everywhere. Don't cheat. Don't look too much at how I scrambled it. It's now obscured, and then okay. So to solve the Rubik's you probably need to rotate the state so it reaches 0 with probability 1. And we run regularly for more than 10 iterations. So to make it simpler, now the solution will be just combination of the following gates. So you're given a bit of here the gates you can use, and then you can add them and just play with that. Let's go ahead. So I kind of see two ways to approach this. So one way to approach this would be with something I recently learned that's kind of something with got to do with something like tomography or whatever. It's basically measure the qubit from different angles and then try to so you kind of see where it is, right? And then if we would measure the qubit from the Z perspective, the X perspective, and the Y perspective, we would kind of know where it is, and we also know where it should go, right? Because if we want this to point to 0 all the time, it basically means that it has to measure 0 all the time by a Z measurement. It's got to measure probably 1 and 0 50% of the times with an X measurement, and also with a Y, but probably there's going to be some kind of phase in there, my guess is. Another thing we could do is we could also use penny lane, but penny lane QML. So penny lane has a really cool tutorial that I did the other day, which is basic qubit rotation. So but I'll do this next time. So because they also integrate with penny lane, so that's awesome. And then basically what I would do is because in this tutorial they train a circuit to actually following the gradient descent technique to rotate from one place to another, and so we could do this. We could use the same technique basically. I guess that could be cool. That could be a cool integration example. But let's get to it. So what happens if I do Z measurement? I don't really need to do that. I shouldn't really need to do that, but because measuring without any operation already gives me the measurement on the Z basis. But let's just do it, or you know, let's better not do this. So can I get rid of these basically? So run the code. I want to run it for 10 iterations. Run this project. See what happens. So what's gonna happen now? Shots 10, that's a circuit, and okay, So we get 80% of the time 0 and 20% of the times 1. So that's not ideal. We would like to kind of get a 1 here all the time. So good. Now let's go back and now let's try to do a Hadamard. So we do a measurement from the x axis, right? Save changes, run. 10 iterations. So what do we have here? Ah, look at this. That's easy. Good. That's nice. So it's all the time 1. Well, this kind of means the state is in probably it's then in the minus state, really. So if I just apply a next gate after that, then we are done. Qubit 0. It's a nice. It could be. I hope there's no trick to it though. So 10 iterations. Now should be always 0. Come on, come on, come on, come on, come on, come on. Here we go. It's 0 100% of the times. So we solved it, right? Yeah, we solved it. That's good. Maybe, I mean, we got some time, so why not try the QML one, the solution? But that's cool. That's actually cool. I like that. It's a nice game. So did I? What was the clues? So what were the clues? The clues were use at least 10 iterations. You only need a combination of X, Y, Z, and H gates. The order of the gates makes a difference, and you can do it with just 2 gates. So we've done it with just 2 gates. So we get like the we get the bonus, right? That's good.